So I wanted to go over briefly, let's see. Just wanted to briefly go over my code that I do have here for the, so I threw this together yesterday for the rabbit class, and I just wanted to go through it to give you guys ideas of some of the logic. So this is a terrible solution. It only wins 44% of the time. Okay? This doesn't do good, but it has but there's some ideas here that I could use. So first thing here is that I've stolen some stuff from the Fox class, right? I put these in your code already, right? Which is have I seen the fox, right? Which starts out as false. Can I see the fox now? Which starts out as false, right? The distance to the fox, the direction to fox, and the current direction I'm going, right? That's one that I don't use. The fox uses that one to chase you down, right? Because if we look at this, the way the fox works, right, is that it let's go ahead and seize our view. It's full screen. Right, the way the fox works is that it ends up going to, let's see. Let's just go ahead and do that. Fox F, and this now. Let's see if I can just quickly get it up that way. Okay, the way the fox works is very simple, right? If it's seen the rabbit recently, move towards its last known location, right? So if I've seen the fox, if I've seen the rabbit, move towards its last known position, right? Because the idea here is that, then the idea here is whether or not it's been seen recently, like not necessarily whether or not I've seen it. I'm just going to move towards where I know the rabbit has been, because then I can get a view of where, from there I should ostensibly be able to see it. Right? So I just keep heading to there, and then if I hopefully can see it, and then basically eat the rabbit by ending up on the same spot it is. So my rabbit just simply is, the code is very simple right now. It will just run away from the fox. Okay, so rabbit. Right, so the rabbit, on the other hand, the way I decide its move is that, like here, I've got a variable I didn't use. Can I see the fox now? That is not true, right? It starts out as not true. And then what I do is that I look at all the directions. So I start at minimum direction and go up to and include the max direction, right? So I look through all 8 directions around me. And if so basically I look in all the directions and ask, is the fox in my line of sight? Can I see the fox? Because of course, if I can see the fox, what does that mean?
Fox can see me.
Exactly, right? Fox can see me. So I can see the fox. Now I have seen the fox. I figure out the direction to the fox, right? Because I would be the direction I'm currently looking. And the distance to the fox would be the distance in that direction, right? Distance returns the distance to the closest thing in that direction. Now, right, that's either going to be the edge of the board, or a rabbit, or a fox, or a bush. And then I say, if I'm keeping track of when I saw the fox, like how many turns ago, if I want to have some memory about how recently I saw the fox, I can keep track of that. I don't really use that too much. Right, if I can see the fox now, or I saw that fox less than 3 turns ago. The first thing I did is that basically, let me move those off, because those were improvements I was going to make and decided against it for the purposes of learning. So since the fox is basically going to be, right, so the fox is in a certain direction. So here I'm using model.turn, and this is really the reason I'm kind of presenting this, so that I can show you guys model.turn, right? So I've got a function call inside a function call, right? I've got the direction to fox. That's the direction the fox is in. Now, model.turn provides me with a way to basically figure out a direction that's a certain number of degrees away. So direction to so let's look at model.turn, right? Model.turn, given the direction and the number of times to make a 1/8 degree turn, 1/8 turn clockwise, return the resultant direction. So that means, right, so I'm going to turn clockwise, which means that basically that if I give like if I'm given north, okay, and 2, that means then I'm going to turn 45 degrees and then another 45 degrees, which will make me face east. If I'm given north and 4, it will return south. 4 will return the exact opposite direction, right? If I'm given -4, I'll turn counterclockwise, okay? So this is actually very, very useful. So I ask, okay, give me the direction that's directly away from the fox, right? This model.turn direction to fox and 4, that gives me the direction that's exactly away from the fox. That seems nice and useful because, of course, the fox is...
Wait, where'd you put this? Right.
This isn't in the code. I'm recording this right now. I'm showing you what I threw together yesterday. So I'm showing off these functions. Okay, this is something I wrote. So this distance, model.turn, direction to fox, number 4, right? This will turn me in the opposite direction, right? Number 4 says, get me the opposite direction, right? And this dot distance says, how far away, how much open space is there in the opposite direction, right? This dot distance says how far can I go in this direction, right? Then I do this for directions 3 and 5. Directions 3 and 5, well, if the fox is facing this way, okay, then 4 is this way, okay? 3 is this way away from the fox, right? And 5 is this way away from the fox. So basically, these are the directions that are going away, right? Going at a 90-degree angle isn't exactly going away from the fox. But this way and this way are directions away from the fox, as well as going straight away from the fox. So I just simply get all those distances, which are useful. Now, this is a terrible algorithm because I'm biasing running straight away from the fox. That would work if there's no obstacles and I never have to turn, okay? So what I do is that basically I say, hey, so ignore this bit right over here, right, for right now, this if statement for right now. Then what I do is I got these 3 things and I compare the distance. If the distance straight away is, so here I could then figure out what the best distance is, right, with these calls. Int.bestDistance is equal to math.max, distance straight away, math.max, distance left away, distance right away. So math.max, given 2 numbers, it returns which one is bigger. It's a really easy function to write, but it's also really easy to, it's also useful. So given 2 numbers, right, give me the bigger one. Well, the other number happens to be a function call, which is the bigger of the right distance and the left distance. So I figure out which distance is basically how much distance I can go. All right, and if anybody needs this code afterwards, you can come over here and I'll get it to you if you want to try using mine as this. But mainly I'm trying to give you guys the idea of what some strategies the rabbit could use for your own solution. Okay, so if my distance straight away is equal to the best distance, right? If running furthest away, if running straight away gives me the most space, I do that. If running to the diagonal gives me the left, I do that instead. So I run straight away unless I have anything better. Okay, so that's not actually a great strategy, which I will demonstrate right here, right? Oh, and by default, basically, if I don't do this stuff, otherwise I'm just going to stay put. What was your question? What? Yeah, distance gives me the distance I can go until I hit something. Okay, distance gives me the distance I'm going to go until I hit something, be it a bush or an edge. I can't distinguish what with distance. Look tells me what it is. Distance tells me how far away it is.
So can I use the view? I tried to use the view and to get the model of an edge or
So look will return either, so look, right? It's going to return either it will return one of four numbers. It will return a, let's see. It'll return a 1 for a fox, right? Look will return a 1 if there's a fox, or a 0 if there's an edge, a 2 if there's a rabbit, or 3 if there's a bush. That's what it will do. Okay, so let me go ahead and go to Rabbit Hunt and go ahead and run this. And now let's see how this, and you'll see that basically this is going to lose quite a bit now. Okay, so here we go. My rabbit doesn't really do anything because if it can't see the fox, it's, and you notice that basically it moved away from, so there it was a bit hard to see, but I'm going to go ahead and notice how it gets caught. So I'll replay it. Run. Because this is actually perfect, right? The fox is moving around. Okay. And now let's go ahead and run with what my strategy does. Oh, I can see it. There's the most space by going diagonally. And then the fox now, it's still moving towards the rabbit because what did it say? It said, its strategy says, I'm going to go until I hit the space that the rabbit is going, right? I'm going to go until I can find, I'm going to go until to the space where I last saw the rabbit. I get there, kind of, and there's an edge there, so I'm going to try to go around that bush. So now watch what happens. What happens, especially with my rabbit. So now,
faster than a rabbit?
no. Now watch, right? The rabbit doesn't move as the fox closes in on it because the distance away from the because it's equally distanced to run away from the fox straight away or away to the left or away to the right. So as soon as I get to a dead end, as soon as I get basically to a corner, the fox eats him. Okay, so the next thing I had to do was this if statement as a result, right? Which said, basically, okay, so if the best distance going directly away is 1. In other words, if going directly away from the fox leads me into an edge or a bush or something, then I'm at a dead end, which means I can't go away. I either have to go, I have to turn, essentially. I have to turn by going at 90, I have to go a 90-degree angle away from the fox in some direction. So now if we go ahead and run Rabbit Hunt, let's see what happens. My guy will now, right? So now we run this. Now my strategy will win about 40% of the time. So watch this. See, now he's going to the end, and watch what happens. He goes around the turn, and now he's going away. And now he's going away from the fox. And now that was interesting. The fox is retreating. Why? Because he lost line of sight with the rabbit. So now, as you can see, it's still chasing it. And the fox will be able to gain on it probably. Might not be able to gain on it quickly enough. Nope. So the rabbit escapes this time around with the strategy because it's just simply, if it gets stuck, it tries to go around it. I said if you need to come over afterwards, you can. So don't worry about it. I care way more about you understanding what's going on than you being able to get it verbatim, because otherwise it's not going to mean anything. So what's going on here? I get the distances. If I'm at a dead end, I then just go one direction. Otherwise, I choose another direction. So the best solutions I have seen, by the way, for this puzzle involve basically having a different strategy based on if you can see the fox, then how far away can you go? And then realizing that basically all that matters is getting out of the line of sight of the fox. If the fox is right next to you, there's really not much you can do. you're probably gonna, unless you're probably gonna end up being get eaten. But otherwise, if you've got some distance and you can get some distance, then you're gonna do fine.